Next.js introduces a lot of different concepts: server components, server actions, partial pre-rendering, cache components, streaming, static and dynamic rendering, and so much more. So it's very easy to make mistakes even if you are an experienced developer. And after teaching Next.js for years, I have seen developers make the same mistakes over and over again. So in this video, I want to help you avoid and fix those mistakes. And for that, I've put together an app which walks you through each mistake with real practical code examples, so you know exactly how to fix them and how to handle it the right way. So let's dive in. So I've created a really handy cheat sheet, a handbook that will cover all these common mistakes that I've been talking about in this specific video. So you could use that as a checklist before you create a PR, or before you submit your code for code review, or as you're building your Next.js application. Because as you know, Next.js can get really overwhelming and complex as your application grows. Take a look at the link in the description below. Now I've put together this little app that goes over all the 29 mistakes here. So let's go over these mistakes one by one. The first one is marking the page as a client component. Now, the rule of using server and client components is that if you mark the root page a client component, the entire tree is then rendered on the client, which is your browser, which means you lose all the performance benefits of server components. Now, don't get me wrong, if something needs to be rendered on the client, we should let it. However, I think I've seen quite often that people just slap in a use client just because they don't understand how to architect their code. So let's take a look at an example. We have this component called Hello Next.js. The entire page is in fact a server component. So let's dig into the code. We have all these different folders for each mistake. This entire page is a server component. Why? Because we have not added anything here. We have not added use client here, which means this specific page is a server component going to be rendered on the server. Now let's say I want some interactivity that only card component could possibly have. Now instead of adding use client here and adding use client to the card component, a lot of folks just end up adding use client over here. What this means is now not only the card component that is going to be rendered on the client, but this entire page is now going to be rendered on the client, which means if you somehow want to create a server component somewhere else in this page, you won't be able to, because you have made the root page a server component. So this is a bad practice. Don't do that. If you want something to be a client component, only grab that individual piece out as a leaf node, as a child node, and make that into a client component, which will allow you to compose your application better. So in this case, if you want interactivity on the client side, then let's add client here. And this means we can still perform any server stuff here, such as getting the data or anything like that, and we still get the benefits of using the server component. The next mistake is not protecting server actions. Server actions are essentially special functions inside of Next.js or even in the React world, wherein if you add a use server directive in a function, then that function gets exposed as a public HTTP endpoint. What this means is anyone can trigger that specific action because it's a public HTTP endpoint. And so the mistake is that folks are not actually protecting that because they don't understand that that function is in fact syntactic sugar that gets exposed. Let's take a look at an example. Let's say we have this create product form. After we submit this specific form, it triggers the create product server action. Before we actually execute, let's take a look at the code. So here, let's head over to mistake 2. Now, we are calling a create product form here. And as you can see, we have a form. We have a few inputs for product name, price, and description. We have a button, we have some messages, and we're using the hook from React called useActionState that allows us to call a server action, but also exposes state, the actual action, and is pending. So we don't have to create a bunch of use states here. Now let's dig into the server action. In here, we are trying to get the form data, and then we write it to a specific file, and we return that. For example, we write it to a file called products.json. Anytime anyone submits the create product action button, we are going to append to it. So let's take a look at how that looks like. So now, if we just add a product, and let's say we say everything you need to master Next.js. Now I'm going to create product has been created. Now, this new product got added as an object. That's great. Let's do it one more time, but this time let's open up browser developer tools. And now let's do the same thing again. I'm going to change the price to 199. Everything you need to master Next.js, basic plan. Now if I press create product, you can see that an API request got created. At the same time, a new product was added. But now let's say I copy this, go here, copy as a curl request, and head over to the terminal and paste it. Now I got a success message. If we head to the JSON, now you're going to see we have another object here. Anyone could just simply access it. This terminal now can access and create a product. And how is that possible? Because we didn't really protect it. So we need to protect our specific code, our server actions, so that something like this doesn't happen and only our application can create a product. Now, what we need to do here is verify the auth, like verify the authentication, also verify input validation. Do some sort of an input validation and sanitization as well, so that random values are not added here. And lastly, let's also make sure that this specific server action does have access or not, for example. So now if I say if process.n.authSecret is not there, then no one can access it. You can just say success is message this return unauthorized, for example, because this auth secret only comes from our process.environment variable is not there. If we go here and trigger request, there we go. We do get success is false, message unauthorized. So the same request, but we did not insert any data. It in fact gave us success as false. The next one is putting server components get calls inside a server actions file to keep it all together. So this is a very common mistake. Just because we call it server components, we call it server actions, both are server, does not mean everything stays together. That is an empty pattern. Let's take a look at an example. So now we have this specific cart where we retrieve all the products, and we can also add the cart, for example. And now if you take a look at the code, you can see that we are getting the cart here, and then inside of the cart item, we have a button that invokes a server action called as add to cart action, and this just increments the count, for example. Pretty straightforward. Now get cart is invoked in a server component, for example. So if I click on get cart, it in fact is in a cart actions file. Anything that you export in this file is in fact a server action. Why? Because we have this use server directive here. So the fact that we have this use server directive, every function is now exposed as a HTTP endpoint. Now this specific get cart one, as we already took a look at, it's not protected. Now this also has been exposed as a HTTP endpoint. Then you may accidentally expose a secret that you're not supposed to, some environment variable or some data that you're not supposed to, just because you added it in this specific file. So remove this export completely, or move this into a brand new file. I typically like to call a cart.server file. Let's go to the lib and let's create a new folder here. Let's call this mistake 3. And here let's call a cart.server.ts and then add that. And this can be imported from there. And now let's remove it from actions. And this one can be imported from cart.server now. Everything else should remain the same. So just by doing this, now we have move the function that doesn't need to be exposed as a server file, as a server function, and added that. This specific function will be internal to our application. It does not need to be exposed, and you can just still keep it as is. But a lot of folks, just because it's on the server, compose it together. Now, mistake number 4 is that a lot of developers let AI do the coding and simply ship to production. But here's the thing, the code generated by AI is not always right. And don't get me wrong, I love AI. I use it pretty much in everything daily. But I've seen the number of bugs that are introduced by developers simply by shipping it because they trust AI so much, because AI is so smart, and not even review their code. And here's the thing, we've all done it, right? We write code fast, we want to ship something, we're excited. Maybe even use AI tools like Claude or Cursor to generate a function. You simply push the commit and move on. But production code is not somewhere you should do this. It's rarely that forgiving. And here's where I've started to use a tool called as Graphite. Because why not let another AI tool help us with our AI code? It is the next generation tool for code review. It's an AI code review platform where teams genuinely ship higher quality code faster. It sits right in your GitHub workflow and acts as a developer co-pilot for pull requests. Here's how that works. So first of all, let's just go ahead and sign up. If you haven't already, make sure that you do. Since I already have an account, I'm just going to go and log in. I'm going to sign up in GitHub. Again, the fact that it's a GitHub login, it's amazing. This is where you could track all your PRs and so on. You have to sync the repo that you're using. And this is a repo that I have already synced, for instance. And here, let's just type GT. Now, GT is a command from Graphite. And this is a terminal tool. To install it, you would just need to install the CLI for Graphite. In fact, when you sign up, it gives you a bunch of instructions, and the onboarding is really cool. So it walks you through everything. So once you do, you have this. So now we could basically initialize a GitHub repo or create a new branch and commit the changes. So let's just do that. Let's go ahead and type gt create. This will essentially commit all the changes in my GitHub repo. And I'm just going to say commit all to track files. Just say yes, write any commit message. So we can say all the changes. Now let's just save it. And now let's just do all. Okay, so when we said create, it is now going to commit all the changes. We just needed an all command as well. So let's call this branch as mistakes. All. It has already checked in a new branch. If I do git status, then I'm on that branch. The next thing we need to do is just type gt submit. This is going to prepare and submit a PR, and now it has automatically opened us our GitHub repo. Now, what it's going to do is just created the PR, for example, and let's just go ahead and publish the PR. And if we take a look at the PR, it's already automatically going to start reviewing all the changes. For instance, it's going to catch what probably our agent missed. Things like missing edge cases or inconsistent variable naming. If we take a look, if we press AI review, it's now going to review our code as well. So now it's reviewing and is in progress. And luckily for us, the Graphite agent found no issues. However, there are a few comments it has made. Contradictory guidance that will confuse users. Now again, second sentence should likely be something like this. Now again, these are just examples, right, that I've created. And that's pretty much, nope, there's one more. Text contains duplication here, contradictory guidance, and that's it. So these are two issues that it found, which I would have probably missed. And I definitely made those mistakes intentionally because this is a mistakes repo. So I could show you all the 29 mistakes. But that's amazing. So it basically closes the loop, right? Like you write code with AI using Claude or Cursor. It lets you write code fast. But then you can still ship things fast because Graphite will help you make it clean and make the PRs a lot simpler. Now, once everything is done, it's saying it's ready to merge, I can just press merge and merge the changes in as well. And now there we go. That's it. That's all we need. So we are literally leaning on a AI tool for that, which is awesome. The next mistake is using route handlers instead of server components. Now, first of all, you can see we are trying to retrieve the cart here and display a list of products. This stays the same. First of all, we have mistake 4 page here. We have the cart, which we are getting in setting. Then we have a loader here. We are trying to fetch the cart using fetch. And then we have an API here. So if you go to API and route, this is essentially what it returns. It returns the cart information, which is all these different products, right? Product 1, 2, 3, 4. So if we go back to mistake 5, you're going to see that we get the cart, we fetch it, we set the cart over here, we set the loading to false. First, we set the loading to true. And then later on, we just loop through them and display it. Now, all this code that we need, now we also had to make this component a client component because we had all these different use state handlers. The challenge here is that, do we even need it, right? Do we need a separate route handler for that since this is a GET request? Now, this should be your first sign. If you're trying to create a GET request here and nothing here, like you don't need the request object from Next or something like that, right? We're just simply returning the cart. The simple get API request, which in that case, what we could do instead is to not use this. So I'm just going to duplicate the page. And now let's fix it. Let's remove use client from here. You can just pretty much call cart equals await get cart. And get cart, we could get it from the lib. And now let's remove all of this code because we don't need it. We don't need use state. We can turn this into an async function. And instead of a loading, let's add a suspense boundary here. For that, let's do cart.items. Let's remove this. You can see how much our code has reduced now. We don't have different loaders. We don't have separate fetch calls. We just need this and we can get rid of this API too because now we are literally getting the information from the cart. And that's the advantage of it. So now if we go back here, it still remains the same because now in fact this is a server component. Then the another advantage to this is, again, we're shipping less code, one less separate API to manage now. Because of this, there's less redundant code and like everything is inside a server component, which follows the latest patterns of server and client components. Now the next mistake is placing a suspense boundary at the wrong level. For example, if we refresh the page here, see one issue saying that uncached data was accessed outside of suspense boundary. Now, first of all, this is an error because in Next config, we have cache components as true for this entire application. And even though we have a suspense boundary, why are we getting that error? If you take a look at the error, it says uncached data was accessed outside of suspense. Now, obviously, we can add a use cache here, which will fix that error. The error will go away. However, we want to show a loader here. We don't want to cache this content at all. Well, the problem is that if we place a suspense boundary at the wrong level, it's not going to trigger the loader. It's in fact useless actually. So we have the suspense boundary here for loading the card. We don't need it here. In fact, we need the suspense boundary. We need to trigger the card list here, then add card list here, move it from here. Now let's save this. Now, if I refresh the page, you're going to see loading cart, and then the cart has appeared. So, and the error is also gone. Again, if I refresh it, loading cart, because you should never place the suspense boundary in the same place as where you're calling the async function. It should always be one level below. So extract the logic out, trigger that here, and then add the suspense boundary around it. You can easily make this mistake. Even a lot of senior engineers make it. So make sure you don't repeat it. A lot of folks mix up use cache and use cache private. A lot of folks don't even know use cache or use cache private exists. Next.js released something called as the cache components, and you could simply add use cache directive or use cache private directive at a page, component, or a function level to simply cache it. Now in this case, we have a list of featured products, a list of items in the cart. Featured products are not necessarily tied to any user. These are just featured products, versus cart is in fact tied to this specific user here. You want to cache featured products or cart, you may think you want to use something called as use cache directive. If you add use cache directive inside here, that's going to be a problem. Here's why. Because this specific cart gets user's cart specifically. And we want to cache this because one, a lot of times users just forget that they added items to cart. They keep revisiting to evaluate cart and so on, if they want to purchase it and so on. So we want to definitely cache this. But the truth is we cannot just add use cache here. That's because the fact that this is accessing user data, that means you're probably using some sort of a cookie to access it. That means we're trying to get dynamic data with cookies, headers, or something like that, which in this case, you need to use something called as use cache private instead. Let's take a look at an example. So now here, if we go to mistake number 7, we have a few components, but let's start from the page. We have the refresh button, as you saw. We have featured products card wrapper, and we have a user card. Refresh button, featured products, user card. Now, if we go to featured products card wrapper, you're going to see this specific get featured product easily be cached now, because if you take a look inside here, it's just fetching the card information, rendering it. Then we have get featured products, which can easily be cached here. In fact, I could just move that from here and place it in here. This way, this entire component is now cached. Because remember, with use cache, you could cache a function, component, or a page entirely. This is straightforward for featured products. But what about user card? And this is specifically tied to the user. If you look here, we have the card component, right? This entire thing could be cached. But if you take a look at user card, now we are accessing cookies, we're getting the cookie, we're getting the card, and so on. You're going to see we get an error saying that accessing dynamic data sources inside cache scope is not supported. If you need this data, use cookies instead. If you need this data inside the function that uses cookies outside of the cache function, pass the required dynamic data in an argument, right? Or you can just simply use cache private. So let's add use cache private. There we go. And now if we refresh it, it's in fact going to be cached now, because it's not going to make the request over and over again. It's in fact just cached. And that's the beauty of using use cache private. But this is definitely a very common mistake, to mix it up and to cache the wrong thing or cache not at the right level when you could be making your app more performant. And the next mistake is using update tag function when you mean to use a refresh function. Update tag is going to invalidate the cache data so that the next request waits for fresh data. Refresh re-renders a server component to reread dynamic data. Server components in general do not re-render because they get the data and that's it. They cache it, they just have the data stored. If you want the server components to re-render just because now you have some data, some mutation that has occurred, you need to use the refresh function. And let's take a look at an example. So over here, we have a static cache data. This gets you information about the stock price. I'm going to update the tag, and now you can see the information has been updated. Same thing if I refresh it, it's going to be refreshed here, for example. If I update the tag, then it's going to update it, for instance. On the other hand, refresh will read this shows the session data, it uses cookies, and it increments the visit count by 1. So now, if I increment it, it returns 3. But if I refresh this entire page, it still stays the same because it's in fact cached. Unless I refresh it, it's not going to do it. So that's the advantage. And this is a server component. And despite that, we are able to get it to re-render it. So let's take a look at the code. So we have the static stock card component and a session data card component. Now we have the refresh buttons, as you saw. The static stock card component. If we take a look in here, what we do is we get the static stock price and then we display it. Then we have the session data card. We get the user session information. Now, if we take a look at the refresh buttons, here's what we do. We update the tag stock price. So now let's take a look at the code. So we have the static stock card and we have a session data card. We use the use cache directive to cache it, right? We also tag the specific cache. So now the fact that this cache has been tagged, we can then purge the cache. But now since we only want to update the tag, if let's say the stock price has changed, then watch what we do in the refresh button. In the refresh button, we basically, this is the refresh button's handler. We are going to update the tag for that specific tagged cache. This way, it invalidates the cache data. Next request is going to wait for the fresh data and so on. Now, this is great. You can see how this can be confusing, right? Because you just want to use refresh to refresh the updated data. But now, in this case, let's take a look at session data card. Inside of session data card, we get the user session and we display it. If we go to get user session, we read the data from the cookies. It's not cached at all. This is dynamic data, for instance, right? We still want this data to be refreshed, for example. How do we do that? How do we get it to re-render? Because here we are tracking the visit count and we are tracking the last visit. All of these are in cookies, for instance. So the way you would do that is inside of refresh and track visit, we increment the count, we set the count, we set the last visit at timestamp. And here we refresh the client to show the updated session data. So you can see how we need to update it. And both of these are server components. The first one is also a server component. The second one is also a server component. So you want to use update tag when you want to refresh your tagged cache. That is a static cache. You want to use refresh when you want a component to refetch the dynamic data. This can still be confusing, so play around with the examples to see how it all works. Use context providers with the app router is incredibly important, but a very common mistake will make your entire application into a client component, even though you have server functionality, which as a result might break things. Let's say we have this component for toggle theme, which allows us to toggle the theme night mode to dark mode and so on. Allows us to switch things. You can see the same over here too. Now, and this is a theme toggle, for example, that allows you to toggle the theme and change the theme. So for this, you would need a theme provider. And typically, you want to wrap your provider inside of your layout file. And if you don't know what a layout file is, it's the root layout. That is where HTML and body elements exist. So obviously, you would think you would need to add a theme provider here. But the thing is, to allow for server and client components to interleave, it's important to make your provider be a separate client component which takes children as a property and re-renders that. So for example, that's exactly what we have done here. We have the theme provider. So if you click here, this specific app that is using the children pattern. Despite taking children as a prop and then re-rendering it, what you're essentially doing is you are then interleaving the client and server component. Now, this is a client component that uses React context, and then just like this, and wrap your entire application. This way, everyone has the theme provider. Everyone can trigger the theme toggle anywhere they like. What this means is the provider rendered at the root, all other client components throughout the application will be able to consume the specific context. And this configuration still allows for server components to be lower in the tree. And it doesn't mean that now the fact that you have wrapped your client component, everything else becomes a client component. You can use this pattern to avoid it. The next mistake is using window or client handlers inside a server component. Now, for example, if you use window, client handlers, or document inside of server components run in a server environment, they're not going to work. If you need a window, document, on-click handlers, anything that needs the browser, you need to move that into a separate client component. If you add a use client directive where you use the window, document, or client handlers, Again, you're going to run into the same problem that you can accidentally make the entire tree a client component. So if it needs browser APIs or event handlers, make it a client component. For instance, this is a page. We call get data here, and get data in fact uses window. The URL is always going to be empty because now this is a server component. We have not listed a client component at all over here. So pattern to fix this is to extract this piece out. So a pattern to fix this is to extract into a URL component here, for example. So we would go to components and create let's say a URL component .tsx that will simply render this p tag, and we will call URL component here, which we will import. Now we are going to move the get data here as well, and this specific get data also needs to move inside the client component. Now we could make this a client here. And now let's save this. If you go back, you're now going to see our localhost. Our URL is localhost 3000 with mistake pen as the URL, which is correct. But before this was empty because we were using it inside of a server component. That's an anti-pattern. Make sure you don't. On adding use client unnecessarily. Just because you use a button or a form does not mean everything needs to be a client component. Sometimes you don't even need that. You could render a button and a form as an HTML on the server. You don't need to do so by adding a use client there. If by just simply adding it, you're forcing the entire tree to be a client component, make it hard for Next.js to optimize it, and simply just making your life harder. So this is an example. This is a sign up form. I'm entering my name, my password, and signing up. Now, if we go back to our app, we have this form, which is a sign up form. It has an input, it has a button, it has a password, right? An email. And we are in fact calling the server action, which is this action right here. It's pretty straightforward, right? But now you may wonder, well, this is a form and we have a button, so we have to make this a client component, otherwise it's not going. We have to make this a client component, otherwise it's not going to work. That's wrong. Now, it's not allowed to inline server functions here. So you may wonder, okay, you know what? I don't need to do this. What I'm going to do instead is call sign up action here. And if we go back, the error is gone, so we think it's working, right? No, it's not. Because now what you've done is this page did not need to be a client component because we don't need any client interactivity, browser APIs or whatsoever. This was a valid pattern and we could simply just do this by invoking the server action. Here we simply want the user to sign up. We don't need any client interactivity here. We don't need to let the user know of anything in this specific use case. So this could be a client component. So don't force everything to be a client component, add a use client directive, or make an error scare you for doing so. A lot of folks don't end up revalidating the data after mutations. That's because they think that data is automatically going to appear. But you have to remember that in Next.js has a router cache, as well as we cache things as well with use cache or some other caching primitive. So it's extremely important that you revalidate the cache. And revalidating means you're telling Next.js, I have some new data. And you would typically do that whenever you are triggering a mutation. So if I add to cart here, watch this quantity does not change at all, even though I'm incrementing the count. Why is that? Because this is a mutation. Let's take a look. For example, if we go to page.tsx, we are trying to get the cart, right? Get cart simply calls cart, and this is the array error, for example. Now we have this additional form at the bottom, and this specific form calls add to cart function, for instance, right? And this is a server action because of this new server director. Now, if we go here, we are incrementing the count of the product. If there is a product, we increment the count. Otherwise, we push a new product. But none of those things are happening either. So what's going on? Why is it that it's not working? That's because we need to call revalidate after we increment it. We need to call revalidate mistakes too. Well, this is the add to cart function that we did so. So now if I press add to cart here, boom, it worked because we added the revalidate. This one is not working either. So let's go to cart item. There's a form here which has add to cart action, which again does the same thing. For example, gets the product ID, increments the count, or pushes a new item. So here, let's also add revalidate function. As we do that, now watch what happens. The cart quantity has been incremented. Same thing here too, as well as here as well. And that's the beauty of it. Now, if I press add to cart, it also works. So revalidate path is extremely important. We're telling Next.js that, hey, I have new data. Please, whatever data or cache you have in this specific route, get rid of it because I have new data. And this is a mistake a lot of people make, that they don't invoke it. Redirecting inside the try-catch block instead of outside the try-catch block. Now, this is a very crazy example and an implementation detail that you need to be aware of. And I do think this is where Next.js as a framework could have done better. Here's why. Especially, you can call the redirect function inside of Next.js to redirect a user on the server side. For instance, we go here, right? We have this example. We have a button that calls redirect to home, the server action, and we are calling the redirect function. That's the job of this. Now, watch what happens. When I redirect to home, why am I not getting redirected? This doesn't make any sense. I'm asking it to redirect me to home. And that's because if you take a look at the console error, you're going to see that we have an error called next redirect. This is because the redirect function, in order to redirect on the server side, throws an error so that it tells the app router, hey, now redirect. If you add it inside a try-catch block, it's not going to work because your catch block is going to catch the error, and that's exactly what happened. So if I add the console log here and say Anki, this is where it got caught. So we need to make sure we move the redirect outside the try-catch block, not inside, so that a catch doesn't catch it. So now if I redirect to home, boom, we are on the home page. Now we are no longer on the this mistakes page. So this is one gotcha you have to know. Then you call redirect either outside try-catch block or rethrow inside catch when appropriate. But again, why would you rethrow? It doesn't make any sense. So make sure you redirect outside. Common mistake I also see is everyone wants to make everything a server component, even when it doesn't make sense. Some pages are just better as client components, especially those with heavy interactivity. Let's take a look at an example. We have this client component. We can reset the timer. We can start the timer. We could change colors here and update it, right? Make it whatever colors we want. This is all heavy interactivity. Could reset it again. These are all different buttons and heavy interactivity. This doesn't need any network round trip, right? It is just client-side code. This is why we fell in love with React to begin with. This deserves to be a client component. We don't need to now shove a server component here, for example. So without client state, every interaction would need a server round trip, so causing a lag and poor user experience. So if you have a lot of interactivity, make sure you stick to using a client component and don't force everything for it to be a server component. So eventually use client components, interactive UIs, just counters, games, drawing tools, drag and drop, live updates, typing indicators, animations, browser APIs such as local storage, geolocation, camera access, complex form validation, auto saving, field dependencies. All these are places you would need client components, and don't force it to make it a server component. Now this is a tricky one. This is a very interesting one too. A lot of people don't use Loading.tsx. Loading.tsx inside of Next.js allows you to show a loader if you're waiting for data, if you're waiting for your page to load. Instead, what a lot of folks do, if I refresh the page, you can see that loading cart indicator, right? What they're going to do is they're going to add the loading cart indicator there. So to implement something like this, they're going to convert a perfectly viable server component into a client component, because now you need to store those states into loading states. For example, here, let's take a look. This page, we have this loading, which loads the cart, and then we render the cart item. Let's add a timer here so that we see the load. When I refresh it, you're gonna see loading cart. We need to await it. So if I refresh the page, loading cart for 3 seconds, and then boom, cart component appeared. Why do we need this to be a client component? All we need is a loader, right? So you may think like, oh, but actually I want to show a loading indicator, so that is a client functionality, so we need to render it. No. What you could do instead is also create a Loading.tsx file that just says loading cart. For example, we could literally get rid of everything, because the only reason why you need to show a loader, then you need a setter for setting the cart, getting the cart, and all that could easily be a server component. And now the fact that you've also had to make this a client component, you don't need to remove this, remove all of this, and now just to get cart, get it, remove the handlers, and remove this too, because now you have a separate loading file. And now here you can do cart maps.item, and that's it. Now if we take a look, if we refresh the page, you can see the loading cart indicator there. If we go back to Loading.tsx and let's add a new promise here. Let's make this a state function. Go back, refresh the page. Now if we refresh the page, you're going to see, and to disable the cache, but you can see that we're no longer using Loading.tsx. If I refresh the page, you should see a loading indicator as we saw. Now, here's the thing. This has reduced our code drastically. We are not forcing a client interaction just because we don't need it. And adding a loading.tsx file has made our life a lot simpler. So lean on that if you're waiting for the entire page to load, otherwise nothing is going to work. Now, a mistake is that a lot of people fetch the same data twice. For example, we have a list of dynamic routes here. If you click on product 1, it takes you to a product 1 dynamic page. If you go back to product, go to product 2, it basically takes us to product 2, product 3, and so on. Now, if you open up browser developer tools and head on to, let's click on product 1 now, and head on to the head tag, and if we take a look, we have a description as well as we have a title. Title is product 1, description is product 1 description. Similarly, if you go to product 2, we have product 2 description and product 2 description here. That means for each dynamic route, we need dynamic metadata. But at the same time, on the page as well, we also need the same information. Product 1 and product 1 description, same thing here and same thing in the other routes too. So obviously, you're going to fetch the same data twice because one you need it for the metadata and the other one you need it on the page, for example. But that's a common mistake. So let's take a look at the code. If we take a look, you simply just link it on this page and we have a dynamic route here. For example, dynamic route has two things. One is the default page export and the generate metadata function, which we'll come back to. So first of all, here we await for the params. That means the ID slug. Then we get the product by ID. And after we do, we return a not found error if it doesn't exist and then render the content. Now, if we click on get product by ID, it simply looks for the card items and finds the item and renders it. We are making the same call in the generate metadata function here as well. In fact, we try to get the product ID and return same call and then return the title and description. Now what ends up happening is it's going to make the same call again and again. So if I add a console log generate metadata, rather let's just add it in product ID. Let's call this console log get product ID. And let's go ahead and clear our console. As we clear the console, let's head here and go to product 1. You can see the same console log has appeared, one for generate metadata and the other one for the actual page. This can't happen, right? We need to fix this. The way you could fix that is by simply adding a use cache directive here. By caching this, you're no longer going to call this twice. You can just simply get the data once. Let's go to product 1. You're going to see that the data is in fact returned from the cache because we have already cached it. If I hard refresh, go back here, you're going to see that first it gets the data and the second time it in fact returns from the cache. And the fact that now we have cached it, we need to add a suspense boundary, but that's for another time. That's the thing. And now it is returning it from the cache directly because it already cached. So that's how you could save it, find repeatable patterns in your code, and then see how you could improve it and cache it. Next, a mistake is not resolving the hydration errors correctly. You've all seen the hydration errors. For example, if I refresh the page, you're going to see a bunch of hydration errors here, right? And hydration errors occur because the same code that's trying to run on the client also runs on the server and it's not handled correctly, then it fails. That leads to a hydration error. And there is more information here that text the content that doesn't match the server rendered HTML. So to fix this, the most common mistake, watch the specific semantics. We have a div, we have a p, and then we have a div and an h2. A p tag can have a div and an h2. That's just something you cannot do. So let's remove this p tag. Now, if we go back here, refresh the page, the hydration errors are gone. We simply check if window is defined or not, because that should give you an idea that that specific code should only run on the client, not on the server. So there you go. So, but the most common one is that semantics are not matching up. Like you're trying to insert an element that should not be basically added to the element that it expects it to. So make sure you follow all of that. Not using Layout.tsx correctly. You may think that layouts are simple HTML and body wrappers, but they are not just wrappers, they are persistent data shells where you could place data if you don't want every single dynamic route or page to re-render. So if there's something common, you're fetching data in every single route, you could move it to layout one level up, such as a navigation, sidebar, or something like that. Data gets fetched once instead of a million times. So let's take a look. We have this dynamic route, and if we go here, we have this sidebar, product 2, product 3, right? And if you go back to products, again, it's linking to some other, let's go back. So if you go to product 1, product 2, and so on. Now here's the thing. This specific sidebar, if you render it inside of a dynamic route each time, what's going to happen is we are going to re-render it every single time. So for instance, if we go here, we just simply link the product, then we go to this specific dynamic route. Now the product links over here, and then we have the specific actual card component here, right? Then we try to get the product by ID, over here and we render it. Now, inside of layout, we only have suspense. But if you think about it, we could move this sidebar that shouldn't necessarily appear in every single spot. This sidebar is in fact looping through the cart. So now if we go to get cart, let's add a console log get cart here. Let's clear this and watch what happens. I'm going to go to product 2, product 3, product 1, product 2, right? Click 3 or 4 times. Get cart gets basically triggered every single time. That means if there are 100 dynamic routes, we are going to basically call get cart 100 times, which is a big problem. And you may wonder, let's just cache get cart, right? We don't have to then. Well, you could, or you could just leverage layout as well. So what we're going to do is we're just going to move anything that can be repeatable. So we could just move aside here and move that inside of Layout.tsx right here, aiming here, for example, right? Call get cart here, make layout an async function, and then that's it. And also move this flex here and move this div 2. We can remove this get cart call completely. And now you can still call, everything works as expected. Let's clear this. Let's refresh the page. Get cart gets called. Other 2 times layout returned it. So let me just clear this. And now if I call product 2, product 3, product 1, right? It only called those logs. It did not call the rest of get cart again and again because that get cart has been cached. So it only will be invoked once, and for every single dynamic route, because of this children pattern and layout wraps or all the dynamic routes here, it's just gonna work. So always move it 1 level up. Not caching repeatable code. Now, if you're using the same expensive code everywhere, cache it and then use that same function everywhere instead of recaching it, refetching it every single time. For example, we have this featured products and we have store statistics. Both of them need the same information. We need product data here. We also need product data here. They're just doing some math here. If I refresh it, both of them are in fact cached. So let's take a look. We're here, we have the product grid and we have product stats. If we go to product grid, we call get products cached. So you can see we have a use cache here, which is extremely important. Then if we go to product stats, we also have get products cache. So that means we also have a use cache here. But what if we did not have this? That means this products are going to get called twice because 2 components are using it. So you can simply slap in a use cache and it's just going to work. You can simply cache it, which is awesome. Using environment variables and client components. You can accidentally leak data if you don't use the proper naming conventions for your environment variables. For instance, we have a server component which has API URL and we have a next public API URL. Let's take a look at what happens. You can see that we are displaying the value of the API URL here and the value of next public API URL here. This is a server component and this is a client component. You can see the value of API URL displayed here. You don't see next public API URL here and you don't see API URL here, not API URL here. Let's focus on API URL first. So if we go to end file, you're going to see we have API URL, which is api-docs.com. Now over here, we're literally displaying, this is a server component, for example. It's a server component and we're displaying process.n.api_URL. And we're also rendering next public API URL in a server component. You can see here, there's no use client here. Now, API URL does get printed in a server component because you can access it. But next public does not work in a server component because anytime you add next_public, it means it's getting exposed not only for the server, but also for the client. So for instance, if we go to this specific component, which is a client component, API URL is in fact process.n.api URL and it doesn't work, it doesn't show. But next public API URL does work. So make sure that you use the proper naming conventions so that you accidentally don't leak data because accessing environment variables in a client component is not safe. So if you need API URL here, that means you can move this 1 level up in a server component over here, get the data and pass that data to the client component versus access environment variables here. But if you go to .env file, this is next public data n. Now, this needs to be just a data n. And next public could be, this is some key, right? This is not some private key. This is just some key. If we take a look, if I copy this, paste it, and over here, if I change this, you're going to see some key does get displayed because it has the next_public there. So that is one thing you should definitely know. that use process.n for server components, but anytime you want to expose something to the client, use next_public. If you have to pass process.n environment variables to client components, it's a problem. You're going to leak data. So that's a big no-no. A lot of folks don't end up using Loading.tsx and Error.tsx files together. They add loading, but they don't add error. So this, as a result, if there is an error that occurs, a UI is going to be stuck. Let's take a look. I have a Loading.tsx here, but there is no error. If we throw a error, let me refresh the page. There we go. An error occurred, no products found. This is going to break your entire application because you're not handling it, and that's a problem. The best way to do so is by adding a Error.tsx here. It looks something like this, wherein you create an Error.tsx, and anytime an error is thrown, a page like this will be shown. For example, error.message, and a link to go back to home. So now you're going to see no products found with a helpful error message. They can try again or just simply go back to home, for example. So they have somewhere to go to other than the error page. So make sure you use both of them together. Trying to use dynamic functions in metadata. Metadata, in fact, must be static unless you explicitly mark the route dynamic. For example, this is a page. We have exported this constant called metadata. Now, if we want something dynamic, instead of trying to call it here, right? So instead, let's say you have like dynamic routes here with ID, and then you have another page here, which is again a dynamic route, right? And now you have this dynamic content, right? This is where you would want to use like a generate metadata function and generate the metadata. But if this is a static page, just use export const metadata. Not using cache function for request memoization. The cache function allows you to memoize requests. This is important for performance as it allows you to avoid making the same request multiple times within the same render. Now, let's say you are in a situation where you cannot use cache, but you still want to cache the data. Then in that case, you could use the cache function from React. For example, without cache, you'll be fetching the same data over and over again. But with cache, you will only be making one request, for instance. So you could simply just use the cache function from React when necessary. A lot of folks end up mixing redirect versus router.push. You want to redirect the user, but you are wondering, well, what should I do? You always need to think that redirect function is for server-side redirects. Router.push is for client-side redirects. If you're doing something on the server-side, you can also use server-side redirect. For example, let's say I have this email and I sign up, tft.com, and sign up, for example. After I hit sign up, I want the user to redirect. Let's see how we can implement this. So for example, let's say we have this form that we saw email and password, and we have a submit button. On submit, we are invoking handle submit, and then we are trying to call this server action called sign up action. So in the sign up action, here's what we do. We get the email and password, we sign the user up, and then it's very simple, right? If there's a user, we return, otherwise not. We call this sign up function, but if test@test.com, then it's true, otherwise not. Now, here's the thing. What we have done now is we have called a handle submit, and then we have pushed the router to home. If we go back here, and if I say test@test.com and test, sign up, it works, right? It simply works. That's because we're still using client-side redirects, but make sure you don't mix them up. For example, in sign-up action, it's fully capable of redirecting. Like we're not showing any validation messages to the user. We're not showing anything. Then why even do all that, right? So we could just simply remove the else condition and just call redirect here. And then we don't even need all of this. For example, we don't even need to store the result. We don't need the router. We can remove the router navigation here, right? And now if we go back and add test@test.com and test and sign up, you still get redirected because even though it's on server side. So keep that in mind, that don't mix up the two. Use server-side stuff for server-side redirects for server-side, and client-side redirects use router.push if you really need it. Typically, if you need to show some sort of a toast message or something like that, some client interaction, you would want to use router.push instead. The next mistake is causing layout shifts by loading Google fonts manually inside of CSS. Now, Next.js has an incredible package called as Next Fonts that allows you to import any type of Google fonts you want. And it also has tree shaking, which means it's only going to include the fonts that you import and not everything else. But a lot of folks, and what they end up doing is they manually load the Google fonts in their CSS file. So that can cause a layout shift because fonts are going to take some time to load. And until the CSS is parsed, this is a huge problem. So what you would do instead is if you go to layout, we have this package called as Next Font, Google. You could import any font you like. I have imported the Fig Tree font, but you could import Inter font and then simply use that here and add it to the class name. This way, you could import any font. And the fact that I added Inter and I used it, it will only be included in the package, nothing else. So keep that in mind. Don't directly import it inside of your globals.css file here and then use it everywhere else and import it manually as a script. Don't do that. Use this as it's more optimized. Meeting your debug logs that clutter the server logs and cost money because ingestion services like Datadog are going to charge as per the number of logs you have. And you may think that, well, it's not going to be that much. Well, it adds up if you have a decent set application. So debug logs should be removed before production. They can clutter server logs and cost money. So the way you would do that inside of Next.js is quite neat by using, for example, you could add compiler, remove console. That's going to remove all the logs. Remove console is going to remove all the console logs in the application code if you just set it to true. And if you want to remove everything except the error, then it's going to only keep the error. So you could simply just add exclude error. But if you want to turn it off completely, you could just do remove console too. And no console logs are going to appear anywhere in production either. Not in development either. So you just want to do something like this. So if it's production, then, or rather, if it's not development, then you want to set it to true. Otherwise, everything else needs to be false. This will help you save time. This will help you save money, but also not leak any insensitive data that your console log may have as well. Images should have sizes prop. By not passing the sizes prop, you are going to load a giant image in a smaller viewport. The sizes prop allows you to specify the size of the image in the browser, so a smaller image is going to load for the viewport size. This is important for performance as it allows browsers to load the image at the correct size. For example, this is the image. And I've already added the sizes prop here. So watch what happens. We go to the network tab. I'm going to go to mobile. Let's load the image. And you're going to see that a 640 by 75 image got loaded. I'm going to go to tablet now. Load the image. Now you're going to see a 920 by 75 got loaded. Let's remove the tablet completely. And then I clear this. Let's refresh it. Now 1200 by 75 got loaded. That's the beauty of it. Use a sizes prop for better performance optimizations. And the way you would do so is by simply using the image component and adding the sizes prop just like this. This will allow you to render the image based on the browser's viewport. Not tagging the cache correctly. The tag functionality or tagging in general in caching is used to identify the cache and then used to purge the cache. If you don't tag the cache will be purged when the page is rendered. Tagging the cache is extremely important because as your application grows, your cache is going to grow. You cannot just simply purge or delete the cache for the entire route because now you're going to refetch all the data. Again, it's going to cost you performance. Let's take a look at the course platform that I've built on top of Next.js. As you can see here, how Next.js works, let's say this is a lesson, and let's say this is a description. We have this button called as mark lesson as completed. Now, if I click this button, mark lesson as completed, and if I purge the cache for this specific route, that means the sidebar is going to reload, the entire page is going to reload, the lesson data is going to be reload. But all you needed to do was to update the little mark lesson as completed status. So why the hell do we need to purge the entire cache? We don't need to. So if you take a look over here, we have get lesson data. Get lesson data gets the lesson data. Lesson completed is false. Then we have this mark as lesson completed. If I click on mark as lesson completed, this specific mark as lesson completed data just gets the lesson ID and just console logs it, for example. So what you would want to do is, again, not want to refetch the entire data, but here you want to just cache it, and then you would want to cache tag it, for example, and then here you want to just update the tag as well in the lesson. So what essentially happens is that then we are only getting rid of the lesson data versus everything else. Now, ideally, you will want to restructure this so that lesson completed is not part of the lesson information. It's somewhere else because typically lesson completion could be in a separate table altogether in a database. But this is just to show that you don't need to purge everything else. They want to update the tag. This way, only that specific information will get updated. And the last one is executing mutations inside of server components. Server components are meant for fetching data. Server actions are meant to execute mutation. If you try to execute a mutation, that means use the server function for executing a mutation, you're not necessarily going to have fresh data. You may run into race conditions because server components are getting the data, a mutation occurs, you're updating the data, that means you're updating the same component, and it's going to be very chaotic and will lead to a lot of race conditions. For example, if you take a look here, we have a form, we have submit button, and let's say we are trying to get some data here. If we use, instead of using a form and executing the mutation here, if we use to execute the mutation here directly, such as sign up action or something like that, right? And then we're also getting the data. That's going to create a lot of problems. For example, if you're trying to add to cart, we are trying to add the card, and then we turn this into an async function, and then we're also, let's say, getting the card as well. And we're doing both of those things at the same time. The add to card function, once you add to card, the card needs to be updated. So this specific component will re-render. The thing is, server components don't re-render. Then you would need to call a refresh function to re-render the server component that we learned earlier. Again, it's like going to lead to a lot of race conditions. You don't want that at all. So don't do this. Just call the get call in the server component. For mutation, you can use the server actions. That's how you would think about it. All right. I really hope you enjoyed this specific video. If you did, make sure to download this specific cheat sheet that I've created that basically documents all the Next.js common mistakes and best practices that we talked about in this specific video. And it's nicely formatted for you, so you can use that as a checklist as you build your Next.js application. Also use it as a checklist before you create a PR, or use Graphite in that case as well. Anyway, I really hope you enjoyed it. As next steps, you should check out this Next.js 16 full course that I have created that helps you build and deploy a production-ready application and teaches you all the best practices as well. Again, thank you so much for watching. Bye for now.